Good afternoon, everybody, and welcome to the Knox County Career Expo session on Computer Information Technology Program demonstration, sponsored by Pellissippi State Community College, which is our presenting sponsor. Now let's hear from the president of Pellissippi State, Dr. Anthony Wise.
Hello, I'm Anthony Wise, president of Pellissippi State Community College. We are proud sponsors of this year's virtual Knox County Schools Career Expo. We live in a region with a growing number of high wage, high demand, high skills jobs, and this week is going to be the perfect opportunity to learn about them. Never too early to learn about those careers, never too early to learn about the pathways to them. I hope you have a great experience visiting with local businesses and industry, local post-secondary partners like Pellissippi State. It's going to be a great week. Learn a lot. Enjoy the expo.
Now we're going to throw it over to Sergio Depris, instructor in the Business and Computer Technology Department at Pellissippi State. He will provide an overview of the Raspberry Pi computer to demonstrate how it can interact with the outside world using external hardware and the Python programming language. Mr. Depris, thank you for joining us today.
Hello, everyone. My name is Sergio Depris, and I'm delighted to be here talking about information technology from Pellissippi State Community College. Let me start by saying that I have been thinking a lot about how to talk to you students that are about to start high school, and how to talk to you about computer programming and how to demonstrate what is the actual job that computer programmers do. And at the same time, I also thought a little bit about how I started working in computer information technology, especially in the area of programming. So initially, I can tell you that probably when I was at your age, I joined a programming club at my high school. And after that, I was lucky to participate in some programming contests. And eventually, basically, that didn't turn out well in the direction of moving to programming. I actually fell in love with physics, and I found very cool how the electromagnetic waves were propagating and were moving signals from one point to another. So I started working in the telecommunication industry, but at that time the internet came, and it was very interesting to understand also how computer networks work. So I went back to the school and I learned a little bit more about the internet, and then start working on information systems. And let me tell you, I was lucky that I had the chance to work in small businesses, and small businesses allow you to work on a little bit of everything. And but part of that, everything that I was able to touch was programming again. So I was able to go back to programming and write some codes for the business I was working on. And ultimately, I became instructor at Pellissippi, and I have been enjoying a lot teaching programming in some of my classes. So what I'm here to tell you about computer programming is that in many videos, I have seen that computer programming can be intimidating for some people. But let me tell you something. Computer programming have a lot of advantages because we are working with something that is very soft, very tangible, that can come from what we type in our keyboard. And computer programming allows us to start from little things and build one thing on top of another. That's one very good thing. Another one is that on computer programming, we can learn. We can learn by doing. We can write some code. We can test if that code works. And this is an amazing experience when you can type something, and from the power of your keyboard, you see something happening all of a sudden. And another beautiful thing of programming is that it allows us to reuse our program, to write program to solve one problem and use that problem, so that code into another problem. And this is awesome. So at the very beginning, you work a lot, but little by little, you are creating a foundations of your code that you can use in multiple places. we doing here? I was wanted to show you one example of how to write a program, and anytime you are going to write a program, you need to have some hardware. You need to have a computer that is going to execute your program. In my case, I have this very tiny computer that you're seeing here in the picture. This is actually the size of a credit card, that computer. And that computer has a little board on the top. The board that you see on the top is containing 64 light emitting diodes, where each one of those diodes they can light on and off, on and off. Actually, they are beautiful. They can actually display multiple colors. But in this case today, I'm just going to show you how to work with the green color. I don't have the code for working with multiple colors is very complex. So I'm going to focus on the green color, and I'm going to focus on one example on how we can learn how to turn on and off those different LEDs. In order to do that, yes, we need software. We need to write a program, and that's actually what programmers do. They are given a hardware, and they are given the task for writing a program on top of that hardware to produce something. Well, whenever you have a computer, you have to have an operating system. That's basically every computer has to have either Windows, Mac OS, Linux operating system, Android in your phones, you name it. And then what do? Well, we need to have a programming language. This is the language that allows us to write and execute the program. So here I'm going to stop for a second, and I'm going to show you how my little computer is working. My little computer is actually represented in this screen, where what I have is a program that allows me to type my code, my programming code. The programming code that I'm going to type is very simple. It's just one instruction to the computer, one instruction. And that instruction is saying, hello class, print hello class. I'm going to execute that instruction, and you will see here, very at the top, at the bottom, hello class, that was printed here, hello class. And I have the power to change that text. I can say welcome. So we have that computer, we have that software, which is in this case is a programming language that is called Python. It allows us to write instructions for the computer to do things. But let's try to do something more complex. And why try to try something more complex? Well, I want to show you very quickly here why programming cannot be intimidating, because if we follow a methodology of steps, we can always write a good program. And every program starts with analyzing the problem, with analyzing the problem that you have. And thus, here I am, presenting you a problem in that matrix of LEDs. I would like to be able to write the letter L. I would like to be able to print the letter L. Okay? So at the beginning, we as programmers, we just see how do we tackle this. Okay, well, we have these beautiful columns and rows, and if we really would like to print the letter L, what we need to do is we need to be able to select exactly which elements of this matrix we are going to turn on. Okay? So how do we do that? Okay, now we know how we know what do we need to do. How do we do that? Well, now we move to the next task. The next task is what programmers do, that what programmers call designing a solution. How this is going to be executed, implemented. Okay? Well, we know that if we fill the matrix in the right sequence of columns and rows, we can print the letter L. So how do we code that? That would be the next question. Next question here, how do we code that? For that, we need to know the language. That's the part that we need to study. That's the part that we need to study. We need to study, we need to learn that. For example, in Python, we need to use the function called function. It's an instruction called setPixel. And that instruction has the beauty of allowing us to tell, I would like to turn on the pixel which is in the column 1 in the row 1 of my table, of my matrix. And that instruction also allows us to set the color. So let's go again one more time to our programming table and let's try to test that. This is, again, that's what I was telling you. That's how you learn by doing. You learn by doing. So here I have this little program. And with that little program, I'm going to set the pixel 0, 0, which is on this corner, be green. And I execute my program, my pixel green. Well, let's see, we like to move to the other way of the row. Let's say we want to move to the column 7 here. So we can actually put here the column 7 and we can execute that. And now, sorry, we move to the row 7. As you see, one thing is what you have in mind when you start programming, another thing is what's happening. And that's why you learn by doing. That's why you learn by doing. I want to move to this corner. Probably I will need to switch my coordinates. And now I move to the other corner. So now we know how to turn on every single pixel on that matrix. So now the task is, how do we make sure that we execute instructions that are going to turn on every one of those elements, one after another, and produce the letter L. That is basically the task. And for that, I have another program here. And in this program, I want to show you the instructions that are written here. As you will see, we have a set of instructions that they are going to print the vertical line of the letter L. Right? So notice how we are maintaining the same column, but we are moving down and down with the number 1, 2, 3, 4, 5, and 6. So we're going to print 6 pixels starting from here. 1, 2, 3, 4, 5, and 6. We're going to turn it on green. And then what's left? The horizontal line of the L. Horizontal line. For that, we just need 3 pixels. All of those pixels, they are going to be on the same row, the row 6, but they are going to move from one column to another column and to another column. So let's see if this is done. Let's execute that program right now. And you see we have the letter L. So now we learn something. That is actually empowering us to do multiple things. For example, let's say right now that we want to print another letter. If we would like to print another letter, maybe what we need to do is we might need to go back to the design table. We might need to go back to the design table and design how that letter will be printed. Maybe we wonder about we are interested on printing the letter H. So once we know how to print the letter L, it's easy for us to go back and say, oh, how do we do the letter H? Well, for the letter H, we actually need to find out what are the pixels that we would like to turn on. And then, based on that information, we write another code and we print the letter L. And that's basically what programming is about. You analyze your program, you design a solution, you code, and then you test it. Now, I was thinking also, okay, but how important is or relevant would be to be able to learn how to turn on LEDs and put them in a table in an order? Well, let me tell you, that's the foundation that the billboards that you see when you travel on the highway, that's the foundation for the billboards. And I actually found a job. I found a job that was looking for a software engineer for a company that is making billboards. And that's part of the job description of that person will be how to install, how to program billboards. And they are requiring some skills. They are requiring programming languages. And so here you have one example of what can be done. I mean, how that skill can be translated into a job. Okay. Information system is very wide. I just want to touch very quickly that there are three big areas. Programmers, they focus on the development part, where they tweak the information systems, they create new information systems, but there are other areas of information system that you might be curious, like operations, how to maintain the day-to-day operation of the system that is, for example, supporting this beautiful conference that we are having right now is working beautiful, is working perfect. We also need people who are going to provide support, people who are going to help the users when they have a problem. And then I just wanted to connect that together. How we in Pelicipi, we can feed the needs for all of these different areas that are needed in the computer information field. And we have four major concentrations. We have the programming concentration. That's the one that I focused today in the example that I talked to you. But we have other concentrations. We have a system administration and management concentration, which is more focused on the area of supporting the information systems as a whole, as a system that is helping companies do business, to provide value to their customers. We also have the networking concentration, where we focus very heavily on how to connect devices and how to protect them. But speaking of protection, speaking of securing devices, securing applications, there's no better program than our cyber defense concentration program, where you learn how to defend systems, computers, software, applications, users from security attacks, but you also learn how to investigate those security attacks. And that's basically what I have for today. I hope you got a better idea of what programmers do, how some people can become programmers, what could be the potential options. And if you have any question, I'm here to answer any question. Thank you everyone for attending.
Okay, Sergio, we do have a couple of student questions at this point. I'll start off with this one. Are all of the coding languages the same? And if not, how do we find what language is being used?
Okay, not all of the languages are the same because number one, they have been created at different times of the technology, and number two, because languages sometimes they are designed to address different problems, and they are also designed to to reflect different ways of resolving problems. And what was the second question? The second question was,
The second question was, how does programming help in our everyday life, and how does this help on the work side of things? You kind of alluded to some of that already.
okay, programming helps a lot in the everyday life. My favorite quote is, it's not, I cannot quote exactly, but I have heard people saying, people that know a lot about programming, not me, that are saying that when you're a programmer, you can become anything you want. Because think about any application right now in science, economy, finance, accounting, you name it, medicine, that is not being, that does not require a program to, to find a solution for a problem.
Okay, I have another question here in regards to salaries. Could you kind of talk a little bit about what the entry level salary would be for someone that is a computer programmer in, say, Python?
I'm not in the job market right now, honestly. I cannot answer that question. I always, and this is a very fluid situation right now. And the best way is to check websites that provide that information. One that is very professional on that is one that is called All Jobs. All Jobs, I guess it's job. I'm not sure about that. I'm not an expert in that question. I'm sorry.
Okay. What would you say is the hardest thing about working as a computer programmer?
The hardest thing for me is to keep up with the changes of the technologies, with the evolution of the software. And this is something that is forever. You need to be catching up all the time, learning new programming languages, paradigms, ways of coding, software libraries. It's a never ending job.
Okay. Can you kind of talk about what the career path would look like in terms of your skill and your growth? Like, how long does it take to become a good coder or programmer?
When I started working, everybody was telling me that it will take you 5 years to start contributing to your organization. And I thought that that was exaggerated. And but let me tell you, um, at the end of the time, I realized that the people that I started working for, they were right somehow. And I guess that between a minimum 3 years is what requires you to be on the field.
Okay, great. So, can you tell us a little bit about some of the classes? Like when you think about, you've shown us how to use a Raspberry Pi. Could you elaborate on some of the other skills and languages that you address in some of your coursework there at Pellissippi?
Well, in Pellissippi, we address the C++ language. We also have classes on Java. We have classes on .NET programming for web development. That's the one that and we do Python.
Great. Could you kind of talk a little bit about your placement rate? Like how many people go through your programs and then get a job right away out of school?
Uh, that's above my head here. I just started teaching. This is my first year, and I cannot answer that question. I don't have numbers.
Okay. Can you tell us a little bit about what you did to get into the career of teaching? Like what some of the coding jobs that you had in the past?
Well, I have my major coding job that I have in the past were actually working with programming language that is called SQL. That is a programming language for databases. But one of the things is that once you learn very well one programming language and you go over all the major concepts in programming, which basically there are not many, then that empowers you to work and teach any other programming language.
So thank you for that. And can you talk a little bit about along that line the systematic approach that coding uses, like how you put things together from one language to the next, like you're saying?
Well, two things here. The systematic approach that I emphasize here today was meant to show people that coding is just the last part of problem solving. But for you to provide and to write good code, you need to analyze your problem. What are you going to do? Then you need to design a solution. And that solution that you design, that's what you translate into code. Okay? That's the methodology. Now, moving from one language to another always require some study, some introduction, because every language stresses different type of instructions, different type of ways of solving problems. And one of the best way to jump into a new language once you know another is to get a tutorial. Get a tutorial, start step by step, and start from simple steps.
Awesome. Thank you so much. Do you have any closing remarks for the folks that are watching?
Well, I wish I was able to see them. But other than that, I wish everyone a good end of this school semester. And if there is any other question, they can reach out to us, and we will be more than glad to help provide any advice.
Mr. Deprez, thank you for joining us. Thank you for the tutorial and the demonstration on the Raspberry Pis. Thank you, guys.
You're welcome. Thank you for having me.